Okay. Hi, welcome. I know you were all expecting to see Paula's lovely face. She is in the back of the room. Paula Brudos, professor at Bunker Hill Community College. But I am also helping her out. She's not feeling that well, but she brought me to also present about this because I am now teaching this course that we're going to discuss. I'm an assistant professor at Bunker Hill Community College, and my name is Jamie LaRue. The presentation of the topic is basically about a course that we're teaching called IT problem solving. And so I'm going to talk a bit about sort of what we mean by problem solving and why define problem solving, talk about the methodology we're using in the course, take a look at some interactive stuff, take a look at how good you are at problem solving. We're going to do a problem, so you'll get a little chance to be a little bit interactive. I know I promised, the description promised that. And then we'll talk about a couple of the problems. There's just 3 that I'm going to discuss out of about 7 that are done in the course, and I'll just kind of summarize them, hopefully briefly, and have an opportunity to ask questions. And we'll also talk a little bit about some of the thought behind this course having to do with computational thinking. You may have attended a presentation earlier by Deborah regarding computational thinking and how we're incorporating it into this course as well. So the methodology, well, let me talk about problem solving first. So generally a widely accepted definition for problem solving, I just pulled this off the web as we all do, right? Problem solving is goal-directed thinking and action in situations for which no routine solution procedure is available. The problem solver has a more or less, should I keep going or should I stop?
You keep going.
All right, thank you.
I'll let you know. I come back.
All right. Haven't had that happen in a presentation yet, so get a new one. So the problem solver has a more or less well-defined goal, but does not immediately know how to reach the answer. The incongruence of goals and admissible operators constitutes a problem. The understanding of the problem situation and its step-by-step transformation based on planning and reasoning constitutes the process of problem solving. And so problems can be defined by different aspects, and we try to, in this course, take a couple of different approaches. If you don't give them a good problem, then they don't know what to solve. So some of the approaches that we have been using is context can reflect different domains, so different content, which may be theoretical or practical in nature. We try to do more practical than theoretical, but we have some of those. Related to an academic situation or to the real world, and problems tend to have various degrees of authenticity, okay, how real world based they are, etc. The scope of a problem can range from working on limited or concrete parts of a task to planning and executing complex actions. And the problem can have well-defined or ill-defined goals. It can have transparent or explicitly named constraints, or it can involve few independent elements or numerous interconnected ones, and all of these different features have to do with how complex the problem is. But oftentimes we create problems that can contain one of these constraints or many of them through the course. But this is to give you an idea of how we kind of started to approach creating problems. The methodology we teach to students is a STAIR methodology, and this is from Andy Harris at IUPUI. And it's a method that has worked pretty well because it uses very plain language. S is for stating the problem. If you don't know what the problem is or the question you're trying to answer, then you cannot answer the correct question. And oftentimes students immediately get stuck with this one. The T is to define the tools. What is available to you? We find oftentimes the students want to use tools that aren't available or to go around the problem rather than addressing the problem. We'll take a look at some of these, this methodology when we address a problem here. A is to define the approach or the algorithm. How are you going to use the tools? In what order are you going to do things? What is essentially the step? I is implementation. Why is this not the end? Well, because oftentimes we implement things and we fail. Work correctly.
bring that to me?
I want to talk over the noise. Yeah, it's the whole floor.
Sounds great. Relating. I think it's legitimate.
All right.
No, I'm good. Okay.